Hello and welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximise, minimise and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Welcome back to part 2 of the Azure Virtual Training Day for Data Fundamentals. So today we're going to take a look at Module 3, where we're going to explore some of the non-relational data services in Azure, and Module 4, where we're going to have a look at some of the data analytics solutions in Azure. Now, in Module 3, we're going to take a look at some of the non-relational data services in Azure, such as Azure Cosmos DB, Azure Storage Account. We're going to also have a look at how to provision and deploy those services in Azure, as well as how to query non-relational data in Azure. So let's get started with Module 3. Lesson 1, explore non-relational data offerings in Azure. So we'll start with Azure Table Storage. Now, Azure Table Storage implements the NoSQL key value model. So in this model, the data for an item is stored as a set of fields, and the item is identified by a unique key. Now, Azure Table Storage is a scalable key value store held in Azure. So you create a table using an Azure Storage account. In an Azure Table Storage table, items are referred to as rows, and the fields are known as columns. But don't let this terminology confuse you by thinking that it's the same as a table in a relational database, because Azure Table Storage allows you to store semi-structured data. So all rows in a table must have a key, but apart from that, the columns in each row can vary. So unlike the traditional relational databases, Azure Table Storage tables have no concept of relationships, store procedures, secondary indexes, or foreign keys. Now, data will usually be denormalized, with each row holding the entire data for a logical entity. So, for example, a table holding customer information might store the first name, last name, one or more of their telephone numbers and addresses for that customer. And the number of fields in each row can be different depending on, the number of telephone numbers or addresses that particular customer might have. Now, in the relational database, this information would be split across multiple rows in several tables. However, in an Azure Table Storage table, this isn't. So we're able to get much faster access to the details of a customer because all the data for that customer is available in a single row. So you don't have to perform any complex joins across tables and figuring out relationships between tables. Now, to help ensure even faster access, Azure Table Storage splits the table into partitions. And partitioning is a mechanism used to group related rows based on a common partition key. So the rows that share the same partition key will be stored together. Now, the key in Azure Table Storage table is that there is 2 elements you need to be aware of. So there's a partition key, which identifies the partition that contains the row, and the row key, which uniquely identifies each row in the same partition. And items in the same partition are stored in the same row key order. Azure Table Storage is commonly used for storing terabytes of structured data capable of serving web-scale applications. So some of these might be, for example, product catalogs for an e-commerce website or application, customer information where the data can be quickly identified and ordered by a composite key. So in the case of the product catalog, the partition key could be the product category, so like footwear, for example, and the row key, which identifies a specific product in that category, could be something like mountain boots. Now, storing data sets without requiring those complex joins, foreign keys, or store procedures in this denormalized ways enables us to have much faster access to our data using Azure Table Storage, which means Azure Table Storage is perfect for things like IoT systems, where we need to capture data very, very quickly and store it immediately. And so if we're talking about IoT device sensor data, each device could have its own partition, and the data could then be ordered by the date and time which those sensor points were collected. Now, Azure Blob Storage is a service that enables you to store massive amounts of unstructured data, or blobs, in Azure. So just like Azure Table Storage, you would create a blob storage account under an Azure Storage account. Now, Azure currently supports 3 different types of blobs. So there is block blobs, page blobs, and append blobs. A block blob is handled as a set of blocks. So each block can vary in size up to 100 megabytes. A block blob can contain up to 50,000 blocks, giving you a maximum size of 4.7 terabytes. So the block blob is the smallest amount of data that can be read or written as an individual unit. And block blobs are used to store discrete, large binary objects that are changed very infrequently. Now, page blobs is organized as a collection of fixed size 512 bytes of pages. And so a page blob is optimized to store random read and write operations. You can fetch and store data for a single page if you need it. A page blob can hold up to 8 terabytes of data. And so Azure actually uses page blob to implement the virtual disk storage for Azure virtual machines. An append blob is essentially a block blob, but optimized to support append operations. So you can add blocks to the end of an append blob. So updating or deleting existing blob isn't supported in append blobs, and each block can vary in size, up to 4 megabytes. Now, the maximum size of an append blob is just over 195 gigabytes. Inside an Azure Storage account, for blob storage, you would typically create blobs inside containers. So a container provides a way for you to group related blobs together, and you can organize blobs in a hierarchy of folders, similar to the way that you would organize files on your file system or disk. And you can also control who gets to read and write the blobs inside that container, or who gets to read and write the container itself. Now, blob storage provides 3 access tiers to help you balance that access latency and storage costs. So the first being the hot tier, which is enabled by default. So you use this tier for blobs that are accessed frequently. So the blob data is stored on high performance media. The next tier is the cool tier. So this tier has lower performance and incurs reduced storage charges compared to the hot tier. So you use the cool tier for data that is accessed not as frequently. So it's commonly for newly created blobs that needs to be accessed initially quite frequently. So you store that in the hot tier, but as time passes, you don't need to access it as frequently. And so in this kind of situation, you can create the blob in hot tier first and then slowly migrate it to a cool tier later on. And this will help you save on some of those storage costs. Now, the third tier is the archive tier. So the archive tier provides the lowest storage costs, but it has very, very high latency, because the archive tier is essentially intended for any historical data that you want to keep, that you don't want to lose, but you're not going to ever really access it. So blobs in the archive tier are effectively stored in an offline state. So typical reading for typical reading latency for hot and cold tiers might range between a few milliseconds, but for an archive tier, this can take up to hours for it to become available. So if you want to retrieve a blob from archive tier, you must actually first rehydrate it. By rehydrating, I mean you need to essentially upgrade that blob into a hot or a cold tier before you can then actually access that blob. So some of the common use cases for Azure Blob Storage includes storing images or documents that you are maybe serving directly to a browser, storing files for distributed access, storing video and audio files that you want to stream, storing data for backup, restore, disaster recovery, or archiving purposes, and storing data that is used for analysis for both on-premises or cloud environments. To ensure availability, Azure Blob Storage also provides redundancy. So your blobs are always replicated 3 times in the region in which you created that Azure storage account, but you can also select geo redundancy, which would replicate your data to a secondary region also 3 times, but this comes at an additional cost. Now, other features that Azure Blob Storage supports includes versioning, so that you can maintain and restore earlier versions of a blob. There is also a feature called soft delete. So if you turn on soft delete, this will enable you to recover any blob that has been deleted or overridden or removed by accident or by mistake. There's also a feature called snapshots. So a snapshot is a read-only version of a blob at a particular point in time. And there's a feature called change feed. So the change feed for a blob provides an ordered read-only record of the updates made to a blob. So you can use the change feed to monitor changes and perform operations. Now, many on-premises systems comprising a network of in-house computers make use of file shares. So a file share enables you to store a file on one computer and grant access to that file to users and applications running on other computers. So this strategy works quite well for computers using the same local area network, but it doesn't scale as well for users who might be located at different sites or if that number of users increases. Now, Azure File Storage enables you to create file shares in the cloud in Azure, and you can then access these file shares virtually from anywhere as long as you have an internet connection. So Azure File Storage exposes file shares using the SMB 3.0 protocol, or the server message block protocol. This is the same file sharing protocol that's used by many existing file shares on premises. Now, that means what you can do is you can actually migrate your file shares to Azure, to the cloud, without having to modify a lot of your applications which access these file shares. So you can also control the access to these file shares in Azure File Storage through authentication and authorization services that's available through the Azure Active Directory domain services. Again, just like Blob Storage, you create an Azure File Storage within an Azure Storage account, and Azure File Storage enables you to share up to 100 terabytes of data in a single storage account. Once you've created your storage account, you can upload files to Azure File Storage either through the Azure portal, or you can use tools like the AZ copy utility. You can also use the Azure File Sync service to synchronize any of your local file shares up with the Azure File Storage. So Azure File Storage is a fully managed service. Your shared data is replicated locally within the region, but it can also be geo-replicated to a secondary region. And all the data is encrypted at rest. And so you can enable encryption for data in transit as well between your Azure file storage and maybe some of your applications that are communicating with the file share. Now, relational databases store data in relational tables, but sometimes the structure imposed by this model can be a bit too rigid, and often this leads to poor performance unless you have a lot of time to really fine-tune some of those implementation problems. So other models, collectively known as NoSQL databases, exist to help overcome some of those issues. Now, these models store data in other types of structures, such as documents, graphs, key value stores, and column family stores. Azure Cosmos DB is a multi-model NoSQL database management system. So Azure Cosmos DB is able to manage data as a partitioned set of documents. Now, a document is a collection of fields, typically identified by a key. The fields in these documents can vary, and a field can contain other child documents. Now, many of these document databases use a format called JSON to represent the document structure. So in this format, the fields in the document will be enclosed in those curly braces, and then each field is prefixed by a name. Now, a document can actually hold up to 2 megabytes of data, including small binary objects. If you do need to store larger blobs as part of a document, you can use Azure Blob Storage and then add a reference to that blob inside your document. Now, documents in a Azure Cosmos DB database are organized into containers. So the documents in a container are grouped together into partitions. A partition holds a set of documents that share a common partition key. So you designate one of the fields in your document as the partition key. Now you need to select this partition key quite carefully because it will relate all your documents together. So this approach will help reduce the amount of I/O or input and output operations that a query might need to perform to retrieve a set of documents for a particular entity. Now, in a document database, for example, if we are looking at an e-commerce system and we are recording the details of customers and the orders that they've placed, we could say partition the data by customer ID and then store the customer and order details for each customer in the same partition, which means to find the information and orders for a single customer, we simply need to query that one partition. Now, it seems like that there is a bit of similarity between Azure Cosmos DB container and a table in Azure Table Storage in that data is partitioned, so documents and Cosmos DB and rows in a table, and that they're both identified by some unique ID within a partition, but that's sort of where the similarity ends. So unlike Azure Table Storage, documents in the Cosmos DB partition aren't actually sorted by ID. Instead, Azure Cosmos DB maintains a separate index. So this index contains not only the document IDs, but it also tracks the value of every other field or the fields inside that document. And this index is created and maintained automatically so that you can use it to perform queries, such as trying to query for a particular field inside those documents in your container without having to scan through the entire partition or all the documents in that container to find the data that you're looking for. Now, Cosmos DB provides a couple of APIs to allow you to access the documents, and it also provides support for other NoSQL database management systems through these APIs. So these APIs are the Table API, the MongoDB API, the Cassandra API, the Gremlin API, and the Table API is essentially an interface that allows you to use the Azure Table Storage API to store and retrieve documents. The purpose of having this API is really to allow you to switch between table storage to Cosmos DB without requiring you to modify any of your existing applications. The MongoDB API is used to support any MongoDB databases that you might already be using for your applications. So MongoDB is another well-known document database. It's got their own programmatic interface, and many organizations actually use it on their premises within the organization. So you can use the MongoDB API for Cosmos DB to enable a MongoDB application to run against your Azure Cosmos DB without having to make any changes to your applications, so that you can migrate the data from your MongoDB database to a Cosmos DB database running inside of Azure and continue to use the same applications to access the data inside Cosmos. Now, the Cassandra API is used to support Cassandra, which is a column family database management system. So this is another database management system that, again, a lot of organizations run on premises. And the Cassandra API for Cosmos provides a Cassandra-like programmatic interface for Cosmos DB. So Cassandra API requests are mapped to Cosmos DB document requests. Just like the MongoDB DB API, the primary purpose of the Cassandra API is really to enable you to quickly migrate any of your existing Cassandra databases and applications without having to make many changes to it to Cosmos DB. And the Gremlin API, well, the Gremlin API implements a graph database interface to Azure Cosmos DB. So again, a graph is a collection of data objects with directed relationships, and data which is held in a set of documents in Azure Cosmos DB can actually be queried using the Gremlin API, which allows you to perform those graph-like queries over your data that's held inside your Azure Cosmos DB. Now, the principal use, the main use of Table, MongoDB, and the Cassandra APIs is really to support any of your existing applications that are already using these kind of data stores as their backend, as their data tier. So if you're building out any new applications and databases, you should really use the SQL API or the Gremlin API. So Azure Cosmos DB is very suitable for some of these scenarios. So if we're talking about retail and marketing, Microsoft actually uses Azure Cosmos DB for our own e-commerce platforms that run as part of the Windows Store and Xbox Live. And Azure Cosmos DB can actually be used quite extensively in the retail industry to, for example, store catalog data or for event sourcing in order processing pipelines. In the gaming industry, the database tier is quite a crucial component for gaming applications. So modern games perform graphical processing on mobile and console clients, but they typically rely on cloud services to deliver these customized and personalized contents like in-game stats, social media integration, and high score leaderboards. Games often require single millisecond latencies for reads and writes to provide that engaging in-game experience. And so a game database needs to be very fast, and it needs to be able to handle massive spikes in request rates, especially during new game launches or new feature launches and updates. Azure Cosmos DB is also able to support IoT systems and devices. So in IoT systems, typically a lot of data is ingested very, very frequently, because these data are being generated on a second-by-second basis. And so using Azure Cosmos DB, we're able to ingest and store this data very, very quickly. So then this data can be used by analytic services like Azure Machine Learning or Azure HD Insights or Power BI to then run analytics workloads on top of it. Additionally, you can also process the data in real time by triggering an Azure function to help filter and to process some of that data as well as it comes into your Azure Cosmos DB database. Lesson 2, explore provisioning and deploying non-relational data services in Azure. Now, there are a couple of ways we can provision Azure Cosmos DB. We can provision Azure Cosmos DB through the Azure portal, which we've already seen how we can do that with the Azure SQL database. So it's a similar approach using the Azure portal. We can also provision Azure Cosmos DB through the Azure command line interface or the Azure CLI. So typically you use the Azure CLI to execute CLI commands through either your command line prompt or through the Azure Cloud Shell. So CLI is suitable if you need to automate service creation. You can store CLI commands and scripts, and you can run these scripts programmatically. And CLI can actually run on Windows, Mac OS, and Linux computers. Azure PowerShell is also another way you can provision an Azure Cosmos DB. So if you're familiar with PowerShell, this is kind of the alternative to Azure CLI. So again, you can use PowerShell commands to script and automate tasks. You can also use PowerShell to create and manage Azure resources just like CLI. And similar to CLI, it's also supported by Windows, Mac OS, and Linux. You can also use Azure Resource Manager templates or ARM templates to execute your deployments. Now, ARM templates is essentially a declaration of your infrastructure and its configuration and set up as code, so as JSON code. So this code that's formatted in JSON can then be used to deploy your Azure resources and provision your Azure resources like in Azure Cosmos DB. So let's take a look at how we can use the Azure portal to provision an Azure Cosmos DB database. So I'm on my Azure portal now, and I'm going to provision an Azure Cosmos DB account. Then I'm going to create a database inside the Azure Cosmos DB account. And then inside that database, I'm going to spin up a container for my documents. So again, I'm just going to look up Cosmos DB from my search bar. I'm going to click into it, and I'm going to go add. Now, I need to provide a couple of configuration details, just like the Azure SQL database that we set up earlier. So I'm going to start with the basics. I need to choose the subscription, which this Azure Cosmos DB will be deployed to. I also need to put it inside a resource group. So I'm going to look up the demo one that I set up earlier. Now, I also need to give my Azure Cosmos DB account a name. This name needs to be unique. So I'm just going to say Cosmos and enter some random numbers. The API section is where you can choose what kind of API queries we want to use against our Azure Cosmos DB databases. So if I open up this drop-down, we can see that the core SQL API is supported, the MongoDB API, Cassandra, Table Storage API, and the Gremlin one. So I'm going to just pick the core SQL API. Now I'm going to leave notebooks switch off. It's still in preview. And for location, this is where I'm going to pick which Azure region I want to deploy my Azure Cosmos DB databases to. So I'm going to go and find East US because that's what I've been provisioning all my services so far. And then in capacity mode, you get to pick between provision throughput and serverless. Now, the difference between the two is provision throughput is essentially dedicated resources for your Cosmos DB to run. Serverless is essentially resources that will be provisioned to you when you need it. And so it's not constantly dedicated to you. So if you've got very light workloads or you're doing dev test scenarios, you can use a serverless option. However, if we're talking about production workloads, you should really consider using the provisioned throughput option because this will give you dedicated resources for your Cosmos DB databases. We can also apply a free tier discount to our Azure Cosmos DB account. Now, this free tier can only be enabled once per account per subscription, and you'll get 400 RUs per second and 5 gigabytes of storage for free. And so RUs means request units, and request units, you can think of it like the computes and a whole bunch of other resources that is needed to actually run your Cosmos DB databases. And this actually increases as the throughput for your Azure Cosmos DB database requirements increases as well. And so if we apply this discount, we actually save around $24 a month. But I'm not going to apply it because I've actually already created an Azure Cosmos DB account, so it's not going to be applicable to me. I can also choose what kind of Azure Cosmos DB account this is. So is it a production one or a non-production one? I'm going to leave the non-production one because this is a demo Azure Cosmos DB. And here I can come and configure things like geo-redundancy, multi-region rights, and availability zones. So geo-redundancy, if I enabled it, this means that I'm going to replicate some of my Azure Cosmos DB databases to other regions, other Azure regions across the world. And so that means if my primary database somehow encounters some errors or a natural disaster happens, I can quickly and easily fail over to some of my other databases running in other regions that are not affected by this disaster, for example. Multi-region rights, if I enable this, it means I can actually create several master copies of my databases located in other regions around the world, other Azure regions around the world. And what that means is I can actually do write operations to multiple different nodes or databases across the Azure regions. And so if I enable multi-region rights, I can write to multiple master databases. Availability zones is all about provisioning an Azure Cosmos DB for high availability. So what that means is your Cosmos DB databases will actually be located into different availability zones, which means that they will be highly available. So if something happens to one zone, you'll guarantee that there is always going to be other running instances in some of the other zones. I'm going to disable and turn off all those features for now, just because this is a demo Cosmos DB. And I'm going to head over to the networking tab. Now, networking tab, similar to the Azure SQL database, this is where you configure the network connectivity. So we can choose from all networks, which means any networks around the world, from the internet, from Azure, from anywhere you're on premises, can access the Azure Cosmos DB. Or we can choose selected networks. So the public endpoint will allow you to only allow access to the Cosmos DB from a couple of networks, or we can select the private endpoint, which means we'll block off all public access to our Cosmos DB account. I'm going to go back and just enable all networks, and I'm going to head over to the backup policy. So backup policy is where you specify how frequently we want to make backups of our Azure Cosmos DB databases and how long we want to retain those backups for. And so you can specify that in the backup interval and the backup retention rates. Now I'm just going to leave all the default values and head to the encryption tab. So Azure Cosmos DB databases supports data encryption, and you can either use the Microsoft Service Managed Keys, managed encryption keys, or you can bring your own encryption keys to encrypt the data that is stored inside your Azure Cosmos DB databases. I'm just going to leave the Service Managed Keys because I don't have a key to provide my Cosmos DB account, and I'm going to head over to the tags section. So again, in the tag section, we can add some metadata to our Azure Cosmos DB account to provide more information about what this particular Azure Cosmos DB account is being used for. I'm not going to add any tags, and I'm just going to head over to review and create. that's going to run a small validation check just to make sure that some of my configuration details I've given it is correct and valid. And once that's passed, I can then go and create my Azure Cosmos DB account. So that's going to submit it to Azure to go and deploy my Azure Cosmos DB account for me. Now, once that has been deployed, we can then create an Azure Cosmos DB database, and then inside that database, we can create a container, which is where our documents will be located. And so, because in wary of time, I've actually set up a Cosmos DB to look at. So while this one actually goes and deploys, let's have a look at a Cosmos DB that I've spun up earlier. So there you go. I have one that I've set up earlier called my DB900 Cosmos DB. So let's just go into it. And again, on the overview page, we can see some of the credentials and details about this particular Azure Cosmos DB account. So I can see, for example, where the endpoint to access my this particular Azure Cosmos DB account is, the region that it's been hosted and deployed to, and a bunch of other details as well. Now, if I go into the Data Explorer tab, this is like the Query Explorer tab that we saw in the Azure in the Azure SQL database, but this one is for Cosmos DB specifically. So if I head into the Data Explorer tab, I can directly create some Azure Cosmos DB databases and containers from the Data Explorer. And as you can see, I've actually created a couple of databases already. So I've got one called Demo Database, and I have one called Volcano. So if we drill down into the Demo Database one, I can see that I've already got a container inside this particular database. So this container is called Demo Volcano Data. Now I can also come up here and create a new container. So I'm going to create a new container, and I need to give my container an ID. So I'm just going to call this my demo container. I need to give this container a partition key. So I'm just going to say this container's partition key will be ID for the the document data I'm going to be uploading to this container. And the throughput is where we specify the number of RUs to provide this particular containers. And so we can see that the lowest start at 400 and the highest is 100,000 RUs we can provision for this particular container. So you can choose between manual, which means if I specify 400 RUs will be provisioned to this container, or I can pick auto scale, which means the RUs allocated for this container will automatically scale depending on our workload needs. And so I'm actually going to turn that off and go back to the smallest one. I can also configure analytical store, so I'm just going to leave that off for now, and I'm going to click OK after that. And that's going to go and then create my container for me inside my Azure Cosmos DB database. The data migration tool can be used to input data to your Azure Cosmos DB from a variety of sources. So it's available to be downloaded from GitHub, and the tool actually guides you through the process of migrating data into your Azure Cosmos DB databases. So you're prompted for the source of data inside the Azure Cosmos DB migration tool, as well as the destination, which is essentially the Azure Cosmos DB database and the container that you want to migrate the data to. So the tool can be used to either populate an existing container or create a new one if the specified container doesn't exist already. And you can also use the data migration tool to export data from an Azure Cosmos DB container to a JSON file that can be either locally hosted or hosted on Azure Blob Storage, for example. If you have a lot of data, the data migration tool can also make use of multiple concurrent threads to batch your data into chunks and then load those chunks in parallel. So let's take a look at how we can use the Azure Cosmos DB migration tool to load some data into the Azure Cosmos DB database that we just set up. So I've opened up the Azure Cosmos DB data migration tool, and this is what it looks like. I've downloaded this from GitHub, and I need to provide it a couple of information. So the source and the target information. So we come into source. Again, we can import from a couple of sources. So JSON files, MongoDB, SQL, CSV, and so on and so forth. Now I'm going to go and add a JSON file from my desktop. So I'm just going to go add files. I'm going to pick this particular Volcano data JSON file, and I'm just going to open that. Now I need to provide the target information, which is essentially my Azure Cosmos DB database to connect to and the container to import to. So I need to come and grab the Cosmos DB connection string, which means I need to go back to my Azure portal and find my Azure Cosmos DB that I set up to grab that connection string. So let's just go do that. So this is my Azure Cosmos DB account. I'm going to go into it, and I'm going to need to go and find that connection string to then be able to input into my target. So if I scroll down a little bit, and it's under keys, so I'm going to grab my connection string from keys. So if I scroll a little bit more, I can find the primary connection string. I'm just going to copy that. Now I'm going to head back to my data migration tool. And I'm just going to paste that into the connection string option. Now I also need to specify the database to connect to. So the database is, if I go back to my Azure Cosmos DB to find out the database name, I'm going to head into the Data Explorer. And I can see that it's called Demo Database. That's the one that I created earlier. So I'm just going to enter demo database into my data migration tool. And then I'm going to hit verify. And this is going to check whether or not it can connect to my Azure Cosmos DB. So that connection is successful. So I'm just going to close this. And now I need to specify the collection or the container to import my JSON files to. And so earlier I created a demo container to import my JSON files to. So I'm just going to specify it's the demo container that I want to import my JSON files to. And I also need to specify the partition key for the data. So I'm just going to say ID as my partition key. And I'm going to change the throughput to match the one that I assigned the container. So I'm just going to change that to 400 RUs. And if I go next, now you can specify some of these advanced configurations as well. I'm not going to. I'm just going to hit next. And I get a summary of my configuration details for this particular data migration. Once you've checked that everything is accurate, we can simply hit import. And that is now going to start importing my JSON files up to my Azure Cosmos DB database and inside that particular container. So let's have a look at how authentication works in Azure. So when a user or application attempts to authenticate, they need to specify the domain to authenticate against. Now, Azure Active Directory will typically require the user or the application to provide some credentials, often a password, to prove their identity. It's also possible to configure multi-factor authentication to reduce the possibility that a fraudulent user with a stolen password is trying to authenticate against the service. For example, you could specify that not only does the user have to provide a password, but they also need to respond to a text or a phone message sent to their mobile device before authentication. Now, if the authentication is successful, Azure Active Directory creates an authentication token for the user or the application to use. Which means when that user or application attempts to access a resource, this authentication token is passed as part of the request to the service. And the token is then used by the service to authorize the access to that resource. Now, configuring an Azure storage account will allow you to access many storage services in Azure, such as blob storage, file storage, table storage, and queue storage. We can even set up an Azure Data Lake storage through an Azure storage account. So let's take a look at how we can actually set up an Azure Data Lake storage through an Azure storage account on the Azure portal. So I'm back in my Azure portal and I'm just going to look up a storage account. I'm going to click into my storage account and ignore the previous ones that I've got. I'm going to go add. And again, I need to provide some basic credentials and other settings to create my Azure storage account. So I'm going to start with the subscription, which is going to be my internal subscription. I'm going to put it inside the same resource group as both my SQL database and my Cosmos database. I need to give my storage account a name, and this name needs to be unique, which means it needs to be a storage account name that no one has used across Azure before. And so let's just call this storage account, and I'm just going to give it a bunch of 9s. Hopefully that's unique. Yes, so that's passed. Now I also need to pick the Azure region to deploy my storage account to. So I'm just going to leave the East US region. I can choose the performance level here. So do I want to create a storage account that is under the standard tier or use the premium tier? So I'm just going to leave the standard one. And under account type, this is where I can choose what kind of Azure storage account I want to set up. So general purpose V2 is actually the newest and latest version that we've got. So I'm just going to keep that as is. And under replication, this is where you can choose the redundancy options for your Azure storage account. So redundancies or replications start from LRS or locally redundant storage. This means 3 copies of your data will be replicated inside the same Azure region and the same Azure data center. Zone redundant storage means that 3 copies of your data will be replicated within the same Azure region, but they'll be distributed across the different availability zones in that region. Geo-redundant storage means 3 copies are replicated within your primary region, as well as 3 copies will be replicated and placed in a secondary Azure region. And there are other redundancy and replication methods as well. You're more than welcome to go and read up on some of the Microsoft docs on exactly how those replication works. I'm just going to go with the lowest one, so the LRS option, and then I'm going to go next to networking. So again, this is where we configure how we want to connect to our storage account. So do we want to enable all networks to be able to access our Azure storage account, or only a selected few networks, or no public access at all, and this storage account can only be accessed via a public endpoint? I'm just going to open this up to all networks. You can also define some network routing rules if you want. I'm just going to leave the default one for now. And I'm going to head into data protection. So data protection, we can do things like configure how we want to recover some of the data stored inside our storage account. So we can turn on point-in-time restores for containers. We can turn on soft delete for the blobs. We can turn on soft delete for file shares if we're using Azure file storage. we can turn on versioning for the blobs, and we can turn on the change feed for the blobs as well. So I'm just not going to turn any of this on because this is a demo storage account, and I'm going to head into advanced. Now, in advanced, we can configure some of our security settings. So do I want security transfer enabled? And I'm going to enable it. You can select the TLS version. So there is the option to pick from 1.0, 1.1 to 1.2. Just going to leave the default 1.2. And under blob storage, this is where you pick those tiers, those access tiers to your blob storage account. So if we enable public access, it means we can have public access to our blob storage accounts. And the access tier is where you choose whether the blob storage account will hold blobs under the hot tier or the cool tier. So I'm just going to leave these default configuration. Now, the data lake storage Gen 2 section is where we want to specify whether or not we want to create this storage account as a data lake storage. And so data lake storage is essentially an extension built on top of Azure Storage or Azure Blob Storage, so that there is a hierarchical file system that you need to define to store your blobs. And this is how you typically would set up a data lake in Azure. So I'm going to actually enable that because I want to set up that data lake storage. I can also come in here and I can set up my Azure file storage if I enable it. I can also set up tables and queue storage. I'm not going to do that for now, and I'm just going to go next to the tags. And again, we can add some metadata to describe exactly what type of a storage account this is. So for example, I can say this storage is a data lake, maybe. And then I'm just going to go into review and create. And it's going to run that validation check to see that I've passed all the right configurations. And once that validation test has checked out, I simply hit create. And that's going to then create my data lake storage for me. This concludes the first part of Module 3. So let's go take a 10-minute break, and then we'll come back and continue exploring non-relational data in Azure.